Hi everyone, welcome to video 3 of 3 for the series on trig substitution for Math 1452 at Texas Tech University, which is Calculus 2. So in the first video, we talked about what trig substitution was and how we're going to use it. In the second video, we looked at an example where we used trig substitution with tangent. And in this video, we're going to look at another example of using trig substitution, this time not with tangent. So first off, whenever we see this integral and it has a square root of an x squared plus or minus some other number that can be rewritten as a square, we're going to call out that square root and we're going to rewrite it as x squared minus 2 squared. So we know that this is going to be related to either sine, tangent, or secant. And when the x is in front, so first off, when we have subtraction, that tells us that s of subtraction tells us it's either going to be sine or secant. And when we have that x in front, that's when it's going to be secant. So we're just going to start off by writing down that substitution over here on the left-hand side. So that means we're going to substitute x equals 2 secant theta because 2 is what's being squared. So that's how I'm going to rewrite this x in my integral. So now I'm going to do some scratch work here on the left-hand side of how to rewrite the other parts of my integral. So first off, I'm going to take a derivative. So dx over d theta equals 2 secant tangent. And then I'm going to do some algebra to solve for dx. So dx equals 2 secant tangent d theta. So that's how I can rewrite my dx. And next I'm going to look at that square root. So I see that if I take my x and square it, I get 4 secant squared theta. And now I'm going to rewrite the square root of x squared minus 4. And this is going to simplify just like it did in the first video, but I'm going to go ahead and walk through the process in this video again. So I see that in these terms inside my square root, I can factor out a 4. And then I'm left with secant squared minus 1. And I know from my Pythagorean identity that secant squared minus 1 is equal to tangent. So tangent squared. So this gives me 4 tangent squared theta. And now, because these are multiplied together, I can apply the square root to both of them. So this is going to be 2 tangent theta. Okay, so now I know how to rewrite all 3 parts of my integral. So I'm going to go ahead and do that. I might point out you don't necessarily need to do all the simplification on the side. I just personally like to because it makes my integral computations less messy, so I can kind of see, dividing it lets me see what I'm doing, but unless your instructor has specifically told you to do things in a certain way, this is just my preference. So I'm going to go ahead and rewrite this integral over here. So my square root became 2 tangent theta. My x became 2 secant theta. And my dx became 2 secant theta tangent theta d theta. So first thing I'm going to do is I'm going to simplify this. So I see that my 2's are going to cancel and I have a secant that's going to cancel as well. So I'm just left with the integral of 2, and then I had 2 tangents in my numerator, so tangent squared theta d theta. So I like to factor out any constants, so I'm going to factor out this 2. And now I need to think about how to integrate tangent squared. So whenever we're doing these trig substitutions, we may need to remember how we integrated powers of trig functions, because we had some rules that whenever we had different powers, we used different identities to rewrite our integrand. So in particular, this integral has an even power of tangent. So what we're going to do here is we're going to rewrite this using that same Pythagorean identity we used on the right-hand side. The tangent squared is secant squared minus 1. And the reason that that's useful for us is because secant squared uses an antiderivative rule, because the integral of secant squared is just tangent, and there's nothing to do, there's no substitutions needed. So when we integrate this, we see that this is 2 times tangent theta minus theta, and then all of that is plus c. So once we have this, we need to use a reference triangle to get back to where we started. So I'm going to go ahead and distribute that 2 first. So anytime we use a substitution, we want to leave our integral like we found it, meaning our original integral was given to us in terms of x, so we should leave our answer also in terms of x. So I'm going to draw a reference triangle down here. And this is theta. And just to remind ourselves, this is the opposite, adjacent, and hypotenuse. And we're going to use the very first thing we wrote down for our substitution, that x equals 2 secant theta. So to use this, I'm going to have x equals 2 secant theta. And then I'm going to solve for secant. So x over 2 equals secant theta. And what this is going to tell us is we know that secant is 1 over cosine. And cosine, we know that when we use SOHCAHTOA, that is adjacent over hypotenuse. So when we take the reciprocal, all that does is flip it. So this is hypotenuse over adjacent. So we can use this to make a triangle. Again, where our hypotenuse is x, our adjacent is 2, and then we can use the Pythagorean theorem. So we know that a squared plus b squared equals c squared tells us that if we're just looking for the side a, that's going to be the square root of c squared minus b squared. So this square root is going to be x squared minus 4. And again, a good indication that you're doing this reference triangle right is that that was the initial square root that was in our integral. So oftentimes this is going to reappear whenever we're doing our reference triangle. So now that we have this, we need to figure out our tangent and our theta. So tangent here is using SOHCAHTOA, opposite over adjacent. So this is going to be 2. Our opposite is the square root of x squared minus 4 over our adjacent, which is 2. And then solving for theta is a little bit trickier. There's multiple ways you can do it, but for now, I'm just going to use this, again, this equation that we had here. And to solve for theta there, I am going to just take the inverse secant. So when I take the inverse secant of both sides, that is going to give me theta. So I'm going to circle this one in blue here. So these two are connected. So I took that initial one circled in blue and I took the inverse secant of both sides to tell me that theta equals inverse secant of x over 2. And I'm going to put that in my integral. Put that in my answer for my integral. So again, depending on your instructor, they may or may not want you to simplify, but I'm just going to notice that those 2's cancel out. I'm going to have the square root of x squared minus 4 minus 2 inverse secant of x over 2 plus c. And this is going to be my answer. So one thing I want to point out is when your answer has just a plain theta, not a cosine, tangent, secant of theta, when we just have that theta, we're going to have an inverse trig function in our answer because that's how we're going to solve for theta. But don't panic if you see that, because remember, from the very first video on this topic, all of this work is motivated by taking antiderivatives of inverse trig functions. So it's completely okay if you end up with an answer with an inverse trig function, because that's kind of where all of this method of using trig substitution started. So if you end up with an inverse trig function in your answer, that's perfectly fine. Don't panic about it. I will note, however, that your inverse trig function may be different than what your neighbor gets, but it's going to be the same answer. So with these trig substitutions, there's lots of different ways your answer can look, but that doesn't mean that it's wrong. It may just look different. Someone may have a different inverse trig function to figure this out, and that's perfectly fine. So lastly, we have a third example here on this worksheet that we're not going to work through fully, but there's an answer that you should get for this integral, but this is going to be our last type. So first off, when we see that square root, we see that we have the square root of 4 minus x squared, and that can really be rewritten as 2 squared minus x squared. Because we have that subtraction, we know that it's either secant or sine, and because our number comes first, that tells us that we're going to use the substitution. X equals 2 sine theta. So that's kind of the first substitution to get you started, and there's also the answer there. So go ahead and try this one out on your own if you want. But that's going to be it for this video series. We hope this helps, and good luck.